So far in this course, we've dealt with algebraic functions like polynomial functions. For example, 4x to the fifth plus 2x to the fourth minus 9x to the third plus 5x minus 3. And when you were in Algebra 2, you did things like you considered its end behavior. And for this one, obviously, we'd consider this one positive and odd. So a positive and odd one, hopefully you remember that, would have end behavior like this. And because the highest exponent is 5, we have 4 terms. And I could find f of 0. When I put a 0 in for x, I'm finding y-intercepts. And I could put a 0 in for x and find, a 0 in for y and find x-intercepts. So I might have 1, 2, 3, 4, something like that. And I could find these x-intercepts and I find that y-intercept and we could graph that. Now, that's Algebra 2 stuff. But I'm just reminding you, that's what a polynomial function looked like. And you also studied rational functions. Now, when you hear rational, think fraction. I've got one polynomial divided by another, and I could compare the degree, the highest degree in both of these, and conclude that our horizontal asymptote is y equals 0 because the degree in the denominator is bigger than the degree in the numerator. And I could certainly find f of 0, again, to find y-intercepts. And then I could set 0 equal to this fraction with the numerator and denominator to find my x-intercepts. And wherever this denominator, I could set this denominator equal to 0 to find vertical asymptotes, and I could graph this. Just a quick reminder that you are expected to know how to do this because you took Algebra 2. As opposed to the algebraic functions, we have something called transcendental functions, which are exponential functions and logarithmic functions. The exponential function f with base a is denoted by f of x equals a to the x. Note, the base a has got to be a positive number, and it can't be 1. Now, if I had f of x equals 1 to the x, if it were 1, then 1 to any power is simply going to be 1. So it's not a very interesting function. We could say that f of x equals 1. And of course, that's just going to be a horizontal line at 1. So we're not talking about the case when a is 1. X is an element of the real numbers. So notice, f is a function of x. Of course, another way to say this would be y. Notice where that variable is. The variable is the exponent, and the base is some positive non-number 1 exponent. Notice f is a function of x. X is the exponent. The variable is the exponent, and the base is some positive number that is not 1.